So in this problem, we want to find the area of the region between this function, this parabola, the x-axis, and the vertical line 0 and 10. And it says the function is positive. This means on the interval from 0 to 2, so that's right here, and from 6 to 10, so that's up here, and it's negative from 2 to 6. So basically that's saying that this function crosses the x-axis at 2 and at 6, right, and it's telling you where it's above and below the x-axis. So if we want to find the area of the region bounded by f, the x-axis, and these two vertical lines, that's this orange shaded area. So you actually have to break it down into 3 separate parts. To find the area of the 2 parts that are above the x-axis, you just integrate like normal. But when you integrate from 2 to 6, you're actually going to get a negative number because that function is negative down there. So to get the area, you just either make it positive or you take the negative of the integral. So let's do 2 of the integrals at least. Let's start with the integral from 0 to 2 of the function. That'll give us this area right here. So do that one right here. Of x squared minus 8x plus 12. So we get a third x cubed minus 8 over 2 is going to become 4x squared plus 12x, and we're going from 0 to 2. Obviously, the antiderivative is the same for all 3 parts, so you only have to do that once. Then we plug in and subtract. So when we plug in 2 here, we get a third times 2 cubed minus 4 times 2 squared plus 12 times 2 minus what we get when we plug in 0, which is going to be 0 minus 0 plus 0, so just 0 there. So 2 cubed is 8, so we get 8 thirds. 2 squared is 4, times 4 is minus 16, plus 24. Combining these two, 24 minus 16 is 8. So it's 8 thirds plus 8. Getting a common denominator, that's 8 thirds plus 24 thirds. I'm rewriting the number 8 as 24 thirds. And then 24 plus 8 is 32. So this area right here is 32 thirds, right there. So now what I wanted to show you, the main part here is this negative. So when we do the integral from 2 to 6 of f of x, just write f this time, we're going to get the same antiderivative. So 1/3 x cubed minus 4x squared plus 12x, and we're taking it from 2 up to 6. So we plug in upper limit 6. I'm going to do a little math as I go this time. So 6 cubed, let's just do that one as we go. 6 cubed is 216 minus 4 times 6 squared. So 6 squared is 36 times 4 is 144. Plus 12 times 6 is 72. Minus, I'm going to put a big bracket here, what we get when we plug in 2. And actually, if you look, when I plug in 2, I'm going to get this, right? I'm still going to get 1/3 times 2 cubed minus 4 times 2 squared plus 12 times 2, which I already simplified and figured out that number is 32 thirds. So I'm just going to go ahead and, rather than just reworking all of it, I'll just use the work I already did. Okay, so we need to figure out this number. It should be negative, and if we get a positive number, it means we did something wrong. So 216 divided by 3, let's see if that's divisible. That comes to 72. So this is 72 right there, minus 144 plus 72. Let's combine the minus 144 plus 72. So that'll be 72 minus 144 is negative 72. Interesting. So that's that part. And then we have minus 32 thirds, so those cancel. And we do get negative. And actually, it's nice to see the graph. It does appear like this area is about the same as this, and that's what this means, is that the integral is negative 32 thirds, so the area there is actually positive 32 thirds. So you do this one more time for this interval from 6 to 10, and then you add 32 thirds plus this 32 thirds plus whatever this integral is to get your total area.